This will be a relatively short slide deck. We level set a little bit of the vernacular and some of the background information security. Now we're going to start diving in a little bit into the material. First, we're going to talk about some approaches to implementing information security. So there's really two major approaches to how we actually implement security. Different organizations kind of approach this different ways, and sometimes both ways, but there's the bottom-up approach and the top-down approach. When we talk about bottom-up, that means that people in the organization are saying, hey, we really need to do this, such and such. And that's going to filter up to management, who is then going to make a decision as to whether or not that should be done. The top-down approach is where management makes a decision that something needs to be done, and it filters down to the users. Now, why do we talk about this in IT security? This is kind of an interesting discussion in that in the old days, IT security was an afterthought. IT security was a couple guys working in a closet, isolated from a lot of the organization, kind of working in the background, and it was sort of an afterthought, right? And these IT security guys would say, okay, here is something that we need to do to protect the data. They would implement it, and then management might come along and say, why can't I access internet radio in my office? I really like to listen to the radio. And they go talk to IT security and make them reverse whatever it is that they did. No matter how good the reason is, they did it, right? And that was kind of how things worked in the old days. And today, that's been flipped around. So in most organizations today, you have a Chief Information Security Officer, which is a C-suite level position, which means it's somebody in upper management, somebody who's just below the CEO. In some cases, they answer to a vice president. In some case, they answer to maybe the chief of operations or something like that. But either way, it's somebody in the C-suite that has a presence for IT security. And they're working with management to come up with what the goals and the policies are for IT security. And then it's filtering down to IT security, which, in some cases, it seems like, maybe one shouldn't be better than the other. But the reality is, if management is coming up with policies and management is coming up with the goals for the organization, then there's a good chance that they are going to come to fruition and that those goals are going to be reached because everyone's going to get behind whatever it is they're trying to do. With a bottom-up approach, if management doesn't agree or management doesn't really have a vested interest in what's happening or what's being suggested, then there's less of a chance of it being enforced. There's less of a chance of it becoming something that's normalized in the organization. So it's important to understand the difference between bottom-up and top-down and to understand what type of organization you're in as far as IT security goes. I would probably argue that at a place like Drexel University, we probably have bottom-up, where there's an IT department that sort of makes decisions about what they think is best, but because of the way higher education works, the people like the professors and the administration might have different ideas, and we end up with a very open system, for example. Whereas a lot of corporate environments, you might see more of a traditional top-down approach to IT security. When you're implementing anything in information systems, it doesn't matter what it is. Really, when you're implementing anything in any industry, for that matter, there's always some kind of a development life cycle. And one of the common ones, and you'll see this in a lot of different courses, is the system development life cycle. The systems development life cycle starts with planning. It leads to analysis, then design, and finally implementation. So what is all this stuff? Well, planning is when you're trying to figure out if whatever it is you're going to do, if you should do it. It's identifying projects that need to be done. So in the planning phase, somebody might say, we need a new system for X. In a simpler example, planning might be me saying, I need a new house. So that's the planning stage. I need a new house. The analysis phase is figuring out what exactly it is that I need in this new house. How many bedrooms do I need? How many bathrooms do I need? Where is it going to be located? How many square feet? What type of construction? What style is this house going to be? What's my budget? How much money do I have? And so forth and so on. The design is where I make the blueprints for the house. So I actually draw up the blueprints. I hire an architect. They create the blueprints. I hire an engineer. They do the plumbing design and the mechanical and so forth and so on. And then finally, the implementation, we build the house. In information systems, we follow the same procedure. We start with our planning phase. We figure out what information systems projects are important. We do our analysis to figure out exactly what the system needs to do, how it needs to work, how people are going to use it. And then we use the design phase to make sure we design something that's going to meet the needs that we identified in the analysis. And then we implement by building that system, by programming it, by purchasing the components, by installing them, testing them, and then finally making it live. So that is the systems development lifecycle. And again, you could take a whole class and learn about the systems development lifecycle. Specifically, systems analysis and design is the class you would take to do that. So that would be the systems development lifecycle. We have a security development lifecycle. Almost every area of IT and really any area of almost every industry has their own special version of that development lifecycle, of that lifecycle I just described. You have those 4 basic steps, but you can kind of expand on that a little bit. In IT security, one example would be investigation, which is very similar to planning. Then you would do your analysis to figure out what exactly it is you're going to need for this security implementation. Then you do a logical design, a physical design, you implement that system, and you maintain it over time. So a few extra steps. This is explained in much more detail in your textbook. There's a table that shows you exactly what we would do at each one of those steps. But it's important to understand, number one, try to wrap your head around the systems development lifecycle. If you've never been exposed to that in another course, it's certainly something that's useful in almost every industry. Almost anything you do, it's a good idea to do some planning, to know, that you're going to do something and that you have a reason to do it. It's good to do some analysis to know exactly what it is you need. It's good to do some design before you try to build it. Imagine trying to build even a simple project. I built a shed in my backyard a couple of years ago, and if I did that without having a design, could I have built a shed without a design? Sure. I could have gone to Home Depot or Lowe's, bought a whole bunch of wood, and just started building a shed. But that probably wouldn't be very efficient, and I probably wouldn't have a very nice shed. But the fact that I knew how wide it was going to be and how long it was going to be, where I was going to put it, what type of construction I was going to be using, is it going to be 24-inch on center studs or 16 on center studs? Is it going to be 2x4s or 2x3s? All those decisions were made ahead of time. You put the design together, and then you build it. One of the examples I like to make about having some methodology, some development methodology is think about trying to write a paper for an English class. I think a lot of us have sat there in front of a computer screen with a blinking cursor on a white screen thinking, where do I even start? What do I do? And really that's one of the hardest things about any project is starting the project, right? You're going to try to do any project. It's that first swing of the hammer. It's the first sentence and so forth. That's the hardest part. But if you plan it first and do some analysis, it makes it much easier because it sort of guides from one step to the next. And it kind of almost goes into autopilot at some point. Take, for example, that English paper where you're sitting and staring at the screen at a blinking cursor. Instead of just trying to write the paper, what if instead you make an outline of what you want the paper to be about? So, for example, if you're tasked with writing a paper about elephants, you might create an outline and say, okay, in this paper, let's see, first I'm going to talk about the history of elephants. I'm going to talk about African elephants, then Indian elephants. I'm going to talk about the state of elephants and so forth and so on until I finally end with the future of, whether elephants are going to be extinct. So you can kind of create a basic outline and then you start filling in that outline with the details until all of a sudden you have everything you need to write a complete paper about elephants without even barely having to think about it. So it definitely helps with complex projects. That was a simple example. Imagine a complex project. IT security has no shortage of complex projects. So it's important to have some kind of methodology to do that. And to that end, IT security is rather complex. And one of the discussions in your textbook is about whether information security is an art or a science. In other words, you can take this course. You can take lots of courses at Drexel to learn about IT security. Does that mean you're going to be able to go out in the field and start implementing IT security tomorrow? Like many fields, there's both an art and a science to this. So in this course and in all of these courses, you're learning the science of information security. You're learning the techniques and the tools and the protocols and the standards we have available to us. But eventually, you'll learn the art of how to implement those. There's sort of the subtleties of how to implement those things. You know, I talked about balancing access versus confidentiality and integrity, and you'll kind of start to learn how to do that balancing act. And that's really what the art is in the art and science of information security. Okay, so three more slide decks in this unit, so stay tuned.